How to improve your digestion. Simple tips for boosting the digestive power of your gut. Today, we're going to tackle the digestive system. We'll discuss how it functions, and then we'll go over some ways that we can leverage that knowledge in order to make better choices, to kind of take on different habits that can actually improve our digestion. Now, it's not a super difficult thing to understand. Digestion is actually fairly basic and it's very simple, provided you don't dig yourself too deeply into the weeds, to understand how your digestive system works and how what happens in one chamber prepares things to go on in the next chamber, etc., etc. So we're going to begin by covering the basics of digestion. We're going to talk about where it happens, which portions of each part of your digestive tract are kind of more suited towards breaking down different macronutrients. We'll also talk about how it happens. What are we talking about? Things like mechanical breakdown, chemical breakdown. We'll also dive into how these things are regulated, how our stomach knows to secrete gastric acid, how our duodenum knows how to dump pancreatic enzymes and bicarbonate into our duodenum. We'll also talk about the anticipatory phase of digestion. This is known as the cephalic phase, and this is the portion of digestion that occurs before food even enters our mouth. The mere thought, smell, or sight of food can stimulate this cephalic phase of digestion, so we're going to discuss that a little bit and how much that contributes to our digestive system function. Next, we'll move on to digestion in the mouth, the stomach, and the duodenum. These are the three primary sites of digestion. The duodenum is the first part of the small intestine. Further digestion does occur beyond the duodenum into the jejunum and ileum, which are the second and third parts of the small intestine, as well as in the colon. We won't cover those portions because it's very similar to what goes on, at least the rest of the small intestine is to what goes on in the duodenum. And what goes on in the colon is actually not us digesting our food. It's our microbiome breaking down the stuff that we can't digest. Finally, we're going to move on into tips for improving your digestion. We're going to leverage this information that we develop by learning about the digestive tract, and we're going to take that to go over 11 simple tips to help you improve your digestion. To begin our little journey into the digestive tract, it's important to understand where digestion takes place. And one of the more important things that people need to understand that they have absolutely no idea about is that digestion begins before we even put food into our mouth. This is known as the cephalic phase of digestion, and it can be stimulated by the mere thought, sight, or smell of food. And if you think about it, kind of, you may have heard of Pavlov's dog, where the simple ringing of a bell every time a dog eats causes the dog to salivate when you ring the bell, even if you don't produce the food. This is the cephalic phase of digestion, and it's regulated by these, current things, thought, sight, or smell of food, but also things we associate with food and potentially even the timing of our meals. Now, as food enters our mouth and these compounds within the food stimulate our taste buds, this further bolsters this cephalic phase of digestion. You're going to get even more saliva production. You're going to get even more gastric acid secretion, and this is really going to prepare the digestive tract for what's to come. Next, as we're chewing, mechanical breakdown begins in the mouth. We're tearing and shredding our food. This is giving the enzymes that will make access to the nutrients. If you swallowed a food whole, you never chewed it, those enzymes would not be able to, kind of say you're chewing an apple, wouldn't really be able to break down into the apple to get access to the carbohydrates because of the peel that's on the outside. Next, as we're chewing, we're stimulating these salivary glands to dump in salivary amylase and lingual lipase to kind of mix in with this food. This is going to help enzymatically break down specifically amylase, which is a starch digesting enzyme. This is beginning in the mouth, so carbohydrates are beginning. The digestion is beginning in the mouth. This lingual lipase will not be active in the mouth. It does not become active in the mouth because the mouth is very alkaline, and it will not become active until it enters a more acidic environment, enter the stomach. So food is going to travel from the mouth to the stomach in the esophagus. Not a lot of breakdown goes down in the esophagus. You could argue that there is some mechanical breakdown because there is segmentation through the effect of peristalsis, which it is mixing the food together and causing some level of mechanical breakdown. But then once we get into the stomach, we're getting more mechanical and chemical breakdown. In the stomach, you're getting churning and grinding of your food, and it's mixing with gastric acid, pepsin, gastric lipase, and that lingual lipase we mentioned coming from the mouth. And this is mixing it all up into what will effectively be perfectly prepared for entering the duodenum, which is where the first part of absorption happens. And in the duodenum, we have mostly chemical breakdown, but we also have some mechanical breakdown. We have the segmentation that happens in the esophagus. But primarily what we're getting in the duodenum is first we're getting a hit of pancreatic enzymes. You're going to get protein, starch, carbohydrate, and fat digesting enzymes. The ACEs, ASES is at the end of the word, that the suffix. They will determine what you're getting. So protease breaks down proteins, lipases break down fats, and amylase breaks down carbohydrate. And then finally, we have something called the brush border, which is going to take the breakdown products of the carbohydrate digestion, and then it's going to take these polysaccharides and disaccharides and break them into monosaccharides so that we can absorb them into our body. So how does digestion happen? Well, first we have mechanical digestion. We have the cutting and the grinding of our teeth, which you're clearly aware of. Your tongue also plays a really big role in molding what's going on in your mouth. Once food enters your mouth and it kind of gets mixed with saliva, it's called a bolus. So within the mouth, the teeth are responsible for a mechanical digestion, that is cutting and grinding your food, pummeling it, smashing it, crushing it with your tongue, and mixing it with your saliva so that you now have a food bolus. You swallow that food bolus, it goes down the esophagus where it undergoes some level of segmentation. Then it enters the stomach for a much more violent pummeling and churning, further mechanical breakdown. This is because whereas you have 2 layers of muscle in, say, your esophagus, small intestine, large intestine, you actually have a 3rd layer in your stomach, which allows you to basically pummel this food, toss it back and forth, et cetera, to get a much better effect of mixing the food together. And then when we get into the small intestine, we get this simple segmentation, which is effectively moving what is now the food chyme. Once it leaves the stomach, it's making these little segments or balls, and it's just kind of segregating pieces of food. Then this is giving your small intestine, the cells that line it, the enterocytes, access to the food so that it can digest further with brush border enzymes, or it can mix the enzymes coming from the pancreas. And finally, it can expose the chyme to the enterocyte so that you can absorb the food. Now we have chemical digestion going on. This happens with enzymes throughout the digestive tract. Again, as a reminder, amylases are going to break down carbohydrates, lipases fats, proteases proteins. And so in the mouth, you're going to get saliva, which contains these enzymes and a few other things to help prevent bacterial growth. In the stomach, you're going to get more protein and lipid digestion. And then in the duodenum, you're going to get basically the whole kit and caboodle. The effect of chemical digestion, how efficient it is dictated by the ACE. So a protease is going to break down a protein. So if you consume only carbohydrate, your proteases really aren't going to help you break down carbohydrates. The activation state. A lot of these enzymes need to be activated, particularly the proteases, because where they're stored, the pancreas, they could digest the pancreas. So they need to be in an inactive state when they're in the pancreas, but activated when they get into the digestive tract. The pH is critically important for enzymatic activity. Too much acidity or too much alkalinity will deactivate an enzyme. pH is really important, which is one of the reasons why we have different levels of breakdown in different areas. The mouth, primarily carbs, stomach, proteins and fats, and the duodenum, all of the above. And finally, temperature. Enzymes are generally more active at higher temperatures. There is certainly a limit to that, but that's not a limit you're going to reach probably within our physiology. Now that we kind of have the basics of digestion down, let's discuss the cephalic phase of digestion. That is the anticipatory phase that we discussed in the overview. The cephalic phase of digestion, its goal is to prepare the gut for digestion simply from environmental signals, whether it be the thought, smell, or sight of food. It can also be Pavlovian, as mentioned, if, say, maybe you're a high school student and you hear the lunch bell, it's at the right time of day, it's the right tone, you'll begin salivating and your stomach will begin kind of churning and pumping out some gastric acid secretion. This mere sight, thought, or smell of food will stimulate these digestive juices. Additionally, once you put food into your mouth, you're going to also stimulate the cephalic phase. So things like umami, things that kind of indicate protein are coming in, may cause a little even more substantial bump in the gastric acid and pepsin secretion, which we'll discuss what those are as we discuss the stomach. But this cephalic phase is going to stimulate salivation. It's going to stimulate the gut-brain axis. Now, the salivation part is important for 2 points. For one, it's going to help you digest your food, but it's also going to secrete enzymes that help break down bacteria. So basically, your brain has been triggered, hey, food is coming. There are going to be some antimicrobials, kind of tossed out into your saliva so that if anything you eat has bacteria in it, you can neutralize that bacteria. But what's really cool about the cephalic phase is that it's actually responsible for 20% of your gastric acid secretion with your meals. So simply smelling the food, seeing it, or thinking about it can kind of give you a fairly substantial increase in gastric acid secretion. At this point, we've smelled our food, we've seen our food, we smelled our food, and now we've put food into our mouth. And this begins our kind of effortful or conscious digestion. So we put these things into our mouth. Taste stimulates saliva production. Saliva contains enzymes, specifically lingual lipase, which is not active in the mouth but will be when it gets into the stomach. And it also secretes amylase, which will help break down carbohydrates, particularly starch, as it enters the mouth. Additionally, we have antimicrobials, electrolytes, and clearly water. What we're going to have happen in the mouth is we are going to chemically digest mostly starch and not a large portion of our starch. We're effectively preparing the starch to be absorbed a little further down the digestive tract. But this is an important part of starch digestion, not chewing your food and leaving it in your mouth to mix with amylase is certainly going to impair carbohydrate digestion. So we're also going to have this little touch of lingual lipase. It's going to be injected into the mouth as well. The problem is the pH in the mouth is too alkaline for this lipase to really have that much effect. So it's simply going to be mixed in with our food bolus so that once it gets into the more acidic area of the stomach, we're going to actually activate that lipase and it'll begin breaking down. But while we're secreting this enzyme into the mouth, it's really not digesting fat at this point. The antimicrobials we're secreting into our saliva are lysozyme, which effectively shreds bacteria. It's kind of just looking for them to shred them. And then immunoglobulin A, which is another part of our immune system that helps fight microbial infections. You might have heard of secretory IgA. This isn't the first place this isn't the only place. This is simply the first place you're going to see IgA. There's secretory IgA throughout the rest of the digestive tract, particularly in the small intestine. It plays an important role in preventing bacteria that might make it through the stomach into the small intestine. We're chewing, which is mechanically breaking down our food. This stimulates saliva. So we're getting, even though we're focusing on the chewing aspect of our breakdown, our mechanical breakdown, this is actually stimulating the chemical breakdown by increasing saliva production. It's also bolstering an antimicrobial effect by secreting lysozyme and IgA into the saliva as well. But this also prepares the gut for digestion, the rest of the gut, not simply just the oral cavity. So there's a study that we're referencing here you'll have access to. So when you chew your food more, what you end up getting is an increased shunting of blood to the digestive tract. This is giving the digestive tract the energy it needs to secrete enzymes and create gut motility and things of that nature. But we're also seeing an increase in oxygen consumption there, which again, this is the developing the energy needed to digest our food. So chewing your food more kind of creates this better kind of shift of resources towards the gut. Whereas, if you simply don't chew your food, you're really gonna have a less boosted effect throughout the digestive tract. From a digestion perspective, when you think of the mouth, think of it as for mechanical breakdown and antimicrobial secretion, as well as starch breakdown. But there are other factors you want to keep in mind, that this kind of chewing and mechanical breakdown will stimulate the rest of the digestive tract. Again, this is probably for many reasons, probably the act of chewing in and of itself, as well as you're mixing this food, you're giving your taste receptors access to the molecules within the food that stimulate these taste receptors, and it's probably communicating throughout the digestive tract. You're getting this initial antimicrobial effect. You're breaking down the starch so that it can be small, so that it becomes a smaller carbohydrate and it's more effectively broken down in the duodenum. And we are kind of tossing in some lingual lipase so that as we mix up this food bolus into our mouth and swallow it, once it enters the stomach, we can begin breaking down that fat, because fat is a rather large molecule, more so than the other two macronutrients. It requires the most processing before we can absorb it. So at this point, the cephalic phase is kind of giving us a little edge. It's given us an anticipatory bump. We've thought about the food. We've seen the food, we've smelled the food. Hopefully you've tasted the food by chewing the food. Most people don't chew the food. You really should chew the food. I know I don't do a great job of chewing the food. It's really important to chew the food. I don't know if I can reiterate this enough. Make sure you chew your food. And the reasoning behind that is, first off, you're mechanically breaking it down. You're chewing it, mixing it with the salivary amylase and the lingual lipase. Then you swallow the food bolus. The esophagus segments it a little bit, so we're getting a little more mechanical breakdown, a little more mixing, so that those enzymes have access to the enzymes. The esophagus is still a relatively alkaline environment, so amylase is still breaking that down. The lingual lipase really hasn't been activated yet, and then plop, plop, the food bolus enters the stomach. We've gotten this anticipatory bump of gastric acid secretion through the cephalic phase. So now that lingual lipase is activated, but what's happening first is this mechanical digestion. Now that third layer, that third muscular layer within the stomach, known as the oblique layer, really gives it some power to pummel the crap out of our food, tossing it to and fro, smashing it up, mixing it up more, mechanically breaking it down through the churning and pummeling. And again, since we've gotten this anticipatory bump from the cephalic phase, the stomach's acidity the stomach has become more acidic, the pH has dropped, and now we have the lingual lipase beginning to, that we had it secreted in our mouth. It's really beginning to kind of access these fats and breaks them down. But now we have the stomach, which is kind of a powerhouse, getting ready to chemically break down our proteins and secrete its own lipase to break down fats. In terms of chemical breakdown, we are primarily seeing the digestion of both proteins and fats within the stomach. Gastric acid secretion lowers the pH within the stomach and activates the protein digesting hormone pepsin. This will help break down proteins. There's also a secretion of gastric lipase, which is a fat digesting enzyme. It's a much more minor role than the protein digesting capacity of the stomach, but it's still there. Additionally, stomach acid lowers the pH within the stomach compared to the mouth, and it activates these proteases and lipases. So in addition to the pepsin that's generated in the stomach, as well as the gastric lipase generated in the stomach, we're also getting activation of that lingual lipase that was secreted into the mouth and mixed with the food bolus when we were chewing our food. From a digestion perspective, think of the stomach as further mechanical breakdown of your food, protein digestion, and the initiation of fat digestion. In our stomach, our food is mixed with acid, proteases, lipases, pounded up, mushed in, and now this food bolus has become what is known as chyme. Chyme is what gets secreted from the stomach into the next segment of the digestive tract, the first part of the small intestine known as the duodenum. So the pyloric sphincter opens, squirts some of this chyme from our stomach into our duodenum, and this begins the process of digestion in the duodenum. First, enteroendocrine cells sense contents within the duodenum, and this causes the secretion of enzymes and bile. Additionally, you get a secretion of bicarbonate from the pancreas, and this increases that pH to bring the pH within the duodenum up to the levels required for the enzymes there to further break down our food. Without this increase of pH from bicarbonate, we may make adequate digestive enzymes, but if the pH is not in the right level, these enzymes will not perform their tasks adequately. There are a number of different enteroendocrine cells scattered throughout the digestive tract, each kind of being more concentrated in certain areas and being responsible for the secretion of different hormones. For example, the hormone ghrelin is secreted by A cells in the stomach. The ghrelin is primarily a sensor of food availability. When we continually eat on the same schedule, we get these anticipatory peaks of ghrelin when we eat our scheduled meals, typically a bit before in anticipation. Interestingly, ghrelin is also believed to play a role in both the stimulation of gastric acid secretion and regulating motility as well. It may be playing some role with other hormones that initiate our migrating motor complex. Hormone gastrin is found within the stomach from G cells. It stimulates the production of gastric acid, and somatostatin produced by D cells actually stops this production of gastric acid. But we want to really focus on these enteroendocrine cells that are found in higher density in the duodenum. We're going to start with the S cells. S cells secrete secretin. Secretin is stimulated by the gastric acid entering into the duodenum, and this causes pancreatic bicarbonate secretion so that we can raise the pH into the level where the hormones or the enzymes that are going to enter the duodenum are going to have their highest activity. I cells release something called cholecystokinin. Cholecystokinin causes gallbladder contraction, which releases bile into the duodenum. It causes the secretion of pancreatic enzymes as well, and it is stimulated by fats and amino acids entering into the duodenum. Let's kind of zoom in a little bit into the barrier of the small intestine, the intestinal wall. We have something called the brush border, which is really important for a couple of reasons. We'll just kind of briefly mention the first reason, since it doesn't really have to do specifically with digestion, and that is absorption of our nutrients. We have these finger-like projections called villi and microvilli, and what these do is they increase the absorptive area of the small intestine. This gives us more surface area to absorb the nutrients from our food. This is really important for health, of course, but it really doesn't have an effect on digestion. However, the brush border does play an important role in our digestion. Specifically, it's the site of terminal carbohydrate digestion. So this brush border is primarily found in the duodenum and jejunum. For the most part, once we get to the ileum, it's really not there because we will have absorbed most of our carbohydrates. So what we have here is we've processed starch, we've begun it in the mouth, we've broken down the large starch molecules into smaller molecules. Once they get into the stomach, any kind of amylase that's bound to starch will continue to break down starch, but there's not extra amylase secreted into the stomach that we are aware of, and the pH in the stomach prevents amylase from further binding to the starch. Then we spit this chyme out into the duodenum, and in the duodenum we have pancreatic amylase, which is further breaking down to where we have oligo and disaccharides, which are effectively sugar molecules. Now these sugar molecules, they're still too big to absorb, so we need to break them down, and that is handled by the brush border enzymes. So, for example, probably a disaccharide you are familiar with is sucrose, which is table sugar. Sucrose is digested by the enzyme, guess the name, sucrase. So sucrase at the brush border will break sucrose into its component sugars, monosaccharides, glucose and fructose, and then we will absorb the glucose and fructose from here. Additionally, lactase will break down lactose. A lot of people, I mention this simply because there are people with lactase deficiency, which makes them to become a little lactose intolerant. But we have these brush border enzymes that are breaking down these kind of bigger, not large, but bigger sugar molecules that we need to break down into the monosaccharides so that we can absorb them. Again, mostly occurs in the duodenum and the jejunum. We don't really see anything in the ileum, so anything that makes it past there is going to make it into the colon. The reason I mention this is lactose intolerance. So if we don't have enough lactase to break down lactose, that lactose is going to make it past the duodenum, the jejunum, into the ileum. Nothing happens into the ileum. It will be deposited into the colon. And now the problem is that you have this higher solute concentration of lactose in the colon, and what happens is this pulls in water, gives you gas, bloating, and eventually diarrhea. So this brush border is really important to make sure we break down our carbohydrates fully. The same thing can happen if you overconsume more complex carbohydrates. If you have these kind of disaccharides floating around in your colon, they can pull water into the colon and cause diarrhea. So the brush border is really important. If diarrhea is a problem for you, this could potentially be a problem that you need to have looked at. Inflammation will mess up the brush border, a bunch of things will. So when we're thinking about what's going on inside the duodenum and the rest of the small intestine as a whole, we want to think of this as an area where we have cleaning up of shop, the further breakdown of carbs, proteins, and fat to their smallest absorbable units, and then the absorption of these macronutrients as well as micronutrients as well. So now that we've covered how digestion works, we could use that information, leverage it to help improve our digestion so that we get the most out of our meals, so that we don't get this feeling of bloating if we have poor digestion, and so that we can overall be healthy because we're breaking down and absorbing the food that we consume. First and foremost, smell and taste your food. Wouldn't hurt to help think about it as well. This will stimulate that cephalic phase of digestion, which is responsible for 20% of gastric acid secretion. Take your time. This is probably an argument for preparing your own food, since you'll be interacting with it more. You'll be more exposed to the smell rather than, simply pulling through a drive-through. Sure, a lot of the times when you're going through the drive-through, you are smelling the food as well, but you're really not interacting with it quite as much as when you're preparing it yourself. Eat on schedule. The hormone ghrelin is released in an anticipatory manner prior to our scheduled meals. So if we always eat at, say, 8 in the morning, noon, and 4 p.m., we're going to get a little bump in ghrelin before each of these times. This can help promote gastric acid secretion, and it may potentially play a role in stimulating our migrating motor complex, moving things along prior to scheduled meals so that we have room for the next stuff. Chew your food. This is going to help mix your food, break it up mechanically so that enzymes can have access to your food. It also prepares the gut by having directing blood flow to the gut, as well as causing greater energy consumption from the organs of digestion. Consume digestive bitters or bitter foods. There are bitter taste receptors in our duodenum, and this actually stimulates eye cells to release cholecystokinin. Hops in particular have been shown to work. No matter what you're doing, you're going to want to eat these kind of in anticipation, maybe 10 or 15 minutes before. This likely also stimulates some level of the cephalic response by tasting these in your mouth as well, but you have bitter taste receptors in your duodenum that are stimulated by bittering compounds. There's a product known as Amerisate, which is effectively a hop mix of bittering hops, and it's released into the duodenum, so it's in a capsule form. No idea if this works specifically for digestion, but it does stimulate cholecystokinin release, and it does seem to reduce food intake, which is partially regulated by CCK, as well as GLP-1, glucagon-like peptide 1, which is also secreted from enteroendocrine cells, and PYY, another appetite hormone. Zinc may also help stimulate eye cells to produce cholecystokinin. This is a rat study. The only reason I kind of included it is simply because because it was a pretty good level of evidence, and there's very low risk from taking zinc. You may be deficient in zinc. I wouldn't take any more zinc than you need, but if you're not getting adequate levels of zinc, this may negatively impact your ability to secrete cholecystokinin. You can also consume free-form amino acids. Free-form amino acids are effectively a supplement that has amino acids in their free form, so they're kind of floating around. They're not part of bigger proteins that need to be broken up. They're already broken up. So this will allow them to flow once they are in your stomach. They'll move into the duodenum, and a higher level of amino acids will be able to stimulate cholecystokinin release, particularly the amino acids tryptophan and phenylalanine. Of course, people who are phenylketonuria, if you don't know what that is, then you don't need to worry about it, do not want to consume excess phenylalanine. So, of course, consult your physician or healthcare provider before doing so. Consume collagen hydrolysate. Collagen hydrolysate is effectively collagen, but it's been hydrolyzed, meaning it's been broken up into smaller peptides, so they're more accessible. You're more likely to break them down further once they get into the stomach, and this will release amino acids that can further stimulate cholecystokinin in the duodenum. You can also use an elemental diet. An elemental diet is effectively free-form nutrients. Rather than food, you're consuming a diet which is all of the elements within food broken down so that your digestive tract doesn't need to break them down. I would not do this as a long-term diet. This is kind of a, help me fix my gut type of diet for some individuals. It might not be right for you, but it is certainly an option if you're having problems with breaking down your food to help kind of get things working again. Be active. Most people underestimate the effect that being more physically active can have on the efficiency of your digestive tract. First off, when we're talking about kind of more intense physical activity such as exercise, we get a shunting of blood from the digestive tract to the muscles. So it's kind of this fight or flight deal where when we're exercising, we're stimulating this fight or flight response, which is going to route resources more towards our muscles and away from our organs of digestion. And now you think about this, you're thinking, well, this must mean I'm digesting my food less, but what it is actually doing is it's kind of putting a pause on motility, and it's allowing the enzymes that have already been secreted with your food to act on your food more. It's giving them more contact time so they can potentially increase their digestive capabilities. Additionally, most of the enzymes, digestive enzymes that we make are more active under higher temperatures, and in fact their highest catalytic activity might be slightly above human body temperature. And so by being more active, you're creating more heat from your muscles and you're increasing your core body temperature. This doesn't necessarily have to be through exercise. You're increasing your body temperature simply going for a walk. Increasing your core body temperature is going to increase the catalytic activity of these enzymes. So even if you make the same amount of enzymes, are going to work more efficiently and break down more food at higher temperatures than they will at lower temperatures. So here you're stimulating these digestive enzymes, not by making more, but by increasing temperature to improve conditions through which they work under. Next, decrease FODMAPs, particularly if you have IBS. FODMAPs are rapidly fermentable carbohydrates. We've done a video on them. I will share a link to that video in the comments section or description of this video. People with IBS have altered enteroendocrine cell density in their duodenum. A low FODMAP diet can restore enteroendocrine cell density. Now, the study we're referencing here, there were some significant improvements. There were also some non-significant improvements, which were trends. And some of these trends were kind of, since it was such a small study, some of the trends might have been significant had a couple of people who were outliers and saw kind of the reverse effect didn't have this situation going on. But most of the people in this study saw an improvement in CCK secreting I cells as well as secreting S cells. So this is something you could try on your own, see what happens, and see if you get this improvement with digestion. It does seem to be a trend that's found in the data that we get this restoration, particularly of serotonin, but also somatostatin, which will help shut off gastric acid secretion. So overall, we're hoping to see a restoration of enteroendocrine cell density by lowering FODMAPs, and then once you kind of restore this density, you're going to try other foods to find out a personalized diet for you. And finally, Rinsing and or brushing between meals. This is really important, and people really don't give this enough play. As we mentioned, in our mouth, we're primarily breaking down starch. And so what ends up happening is if you eat, say, a high carbohydrate diet and you just kind of let that sit in your mouth, that's actually going to make your mouth more acidic, which is going to make the mouth less of an ideal state for carbohydrate breakdown. Carbohydrate breakdown in our mouth requires a more alkaline pH. So when you just kind of leave this food on in your mouth and you just let it continually ferment, this increases the amount of acids made by the bacteria, which will make you less capable of breaking down starch when you put it in your mouth in the next meal. So at the very least, you'll want to rinse out. You can rinse out with water and swallow it. You can use mouthwash if you like. You should certainly be brushing after every meal to kind of remove the bacterial film that is on your teeth as well. Just kind of an interesting side note here. We break down carbohydrates in our mouth, and that requires a more alkaline pH. However, in our colon, we get carbohydrate breakdown at a more acidic pH, and that's because we're not the ones actually breaking down the carbohydrates within the colon. It's actually our microbiome doing it, and their enzymes work better in a more acidic environment. So it's just kind of interesting. Our digestive process is done when we get into the colon, but that's when our microbes kind of take over. We're definitely going to be discussing that in a separate video, improving your microbiome. We have an improving your microbiome series and things of that nature, so just keep that in mind. Finally, understanding how the digestive system works can really help us if we try something that we think should ultimately help us, but actually doesn't. So a lot of people will take something like digestive enzymes because they think they're not making enough digestive enzymes on their own. Now, this may be true, and if this is the case, taking digestive enzymes should help that individual. Now, this doesn't mean that the 11 tips that we previously mentioned won't help you. In fact, chances are they will help you. But if your problem is something else, which is often the case, digestive enzymes won't help you. So what do I mean something else? So as we mentioned, it's not just about digestive enzyme output. It's that those digestive enzymes, A, have access to the food, and they are in the environmental conditions under which they operate well. So for example, if you don't chew your food enough, taking digestive enzymes really is not going to help that, because even if you're making enough digestive enzymes, if they cannot access the greatest amount of surface area of the food that you consume, then they're really not going to break down that food very well at all. And next, we've mentioned that the pH and temperature are really important. So if you have a problem digesting carbohydrates and you are not chewing your food, mixing it with saliva and letting amylase access those carbohydrates, then you will get gas and bloating, because carbohydrates will not fully break down and they'll enter your duodenum, and it'll take even more effort from the duodenum and the brush border enzymes to break down. You're more likely to have sugars that are accessible in the colon that can cause gas, bloating, and diarrhea. However, we also have to look at the pH. So say you're somebody who really doesn't pay any attention to oral care, and your mouth, you eat carbohydrates regularly. This creates acidity in your mouth, which ironically over time is going to inhibit carbohydrate breakdown. So you're really not going to get that initial breakdown of starch in the mouth. It's going to enter the stomach, then it's going to get into the duodenum, and perhaps the pancreatic enzymes don't break it down quickly enough, and you're going to have oligo and disaccharides entering the large intestine, which is no bueno. Additionally, if you do not have enough acid production in your stomach, you won't lower the pH enough to activate the protein digesting enzymes, and you will have poor protein digestion and, of course, fat digestion as well. And finally, if you don't get that bicarbonate secretion from the pancreas into the duodenum, it won't lower the pH there rapidly enough for the digestive enzymes secreted from the pancreas to break down your food, and you'll have the same problem as well. So even if you toss, you may get some minor benefit from digestive enzymes, but if they don't fix the problem, chances are you're looking at an environmental condition that needs to be addressed and not simply a lack of enzyme production. Understanding how the digestive system works can help you identify why things may or may not help and give you direction to where you may be able to improve your problems. Specifically, I always recommend starting with the behavioral factors because chewing your food is not going to have a negative side effect, and but using that cephalic phase of digestion by smelling your food more and interacting with it more, that's not going to give you a side effect. Putting digestive enzymes into your stomach, especially if perhaps your stomach is not secreting enough acid, can be a really bad situation for you. Digestive enzymes from the pancreas are not meant to be in the stomach. If the stomach has the proper acidity, shouldn't be a problem because the enzyme should be inactive, but people with digestive problems have digestive problems, so you're really taking a risk by just jumping right towards digestive enzymes or bile. So there you have it. We kind of went over how the digestive tract works, how you digest your food, where you digest your food, and using that information, we kind of gave you some ideas for improving your digestion. Thanks for listening in. We hope you enjoyed it. As always, before you make any sort of changes to your daily routine with the express intent of trying to improve your health, please go over these things with your healthcare provider. Most of these things your healthcare provider is not going to care about. I can't think of a healthcare provider that would tell you to be less active or to not thoroughly chew your food, but it doesn't make sense to not consult them as well. If you like this video and you would like to see more of it, like and share on social media. Hit the subscribe button below so that you get access to these videos the second they're released, and then you can kind of take a look at the accompanying blog later. And if you have any questions, comments, or constructive criticisms, please drop them in the comment section below. Thank you very much and take care.